Hi everyone, Professor Christina Sover from Cal State Long Beach speaking here. And in this video, we're going to consider quantitative relationships found in Module 3. This is Activity 1 in Chapter 13, I believe. I'm blanking on which chapter it's from at the moment. I apologize. But it's from Module 3, Quantitative Relationships. In this activity, we have different pairs of quantities that are related, whether or not we don't know yet, but they say to consider the value on the right, does it increase or decrease as the value on the left increases? So I'm just going to write a little arrow to say increase on all of these and see what happens for each pair. If something happens that makes sense, then they're related. Um, I would rather provide some sort of insight first before I say, oh, yeah, they're definitely related. And then be like, wait, am I sure? So I always just say, let's pretend that they are and double check afterwards. So, as the number of minutes that have passed while driving a car at 65 miles per hour increases, the amount of fuel left in the gas tank, well, as you keep driving your car, you have to start getting more gas. So the amount of gas in your tank in your car decreases. So they are related. Cool. Number 2, or letter A, I should say, is done. Now letter B. The number of minutes that have passed while driving a car 65 miles per hour. As those minutes increase, the amount of fuel that you've used. Well, if you've used up fuel while you're driving, that means the amount of fuel you used increase. That's why your gas tank decreases. Oh, that's cool. There's an inverse relationship there. As gas amount increases or decreases, the fuel amount that you've used increases. That makes sense. So B is also related. C, the length of one side of an equilateral triangle increases. So the perimeter of the triangle. Well, let's take a look. If we had an equilateral triangle, now I'm going to assume that they mean it's still going to maintain being an equilateral triangle. As one side increases, the whole thing gets bigger. So the perimeter of a bigger triangle should also increase. The reason why I'm saying that one side increasing, I'm going to assume it's the whole triangle to maintain that it's an equilateral triangle, because you'll learn in geometry that there's a limit for how big the sides can be before it's no longer a triangle anymore. They just sort of collapse into each other. And that works out that if the last side is bigger in length than the two smaller sides, it no longer gets to be a triangle anymore. But that's a geometry thing. So this one's also related. We get a bigger perimeter as the length of a side gets bigger. The perimeter of a rectangle. As the perimeter of the rectangle gets bigger, what happens to the area? Well, you would just draw some pictures. Here's a rectangle. And if I get the perimeter bigger, well, it's not saying any consistency bigger. So what if I just made it longer? Would the area increase? Let's say this was worth 2 pieces, this was worth 3 pieces. Yeah, as the perimeter of the rectangle gets bigger, the area of the rectangle should get bigger as well. The reason why I'm pausing here is because if you maintain the perimeter of any figure, there is one that has the most area. You can have a really big perimeter, but the area be really small. So that's why I'm a little bit paused here. Maybe we can explore this one together in student hours. It'd be a good question to go together. More of a brain teaser. Don't know if it's a great exam question, but it's a good brain teaser. Now, as the number of potato chips eaten increases, the number of calories consumed unfortunately also increases. And lastly, the amount of money inserted in a candy vending machine increases, The number of candy bars you receive should also increase. The more money you put in, the more you should get out of the machine. Assuming the machine's not broken and tries to eat your money, right? That happens. But nope, as you put in more money, it should increase. All right. Well, those are those relationships. Now, let's look at some more examples. For each quantity, name another quantity that is related to the amount of money you make from selling lemonade. Well, it's maybe the amount of money you need to buy lemons. Money spent on lemons. Maybe you're going to keep getting lemons. Or the amount of cups used to pour the lemonade. Or if you open up a lemonade shop, the amount of taxes you have to pay, right? Those would increase. What else would happen? The amount of money you make selling lemonade, you'd have a decrease the amount of remaining lemonade, right? The lemonade amount would decrease as you make more money because you're selling it all gone. There's a couple of different ways you could think about that relationship. Now, the amount of fuel you use on a car trip. What's another quantity? Maybe the time spent on your trip. Mm, Time spent traveling. What's something else you could think of? The number of miles traveled on your trip. And lastly, the amount of sales tax that you have to pay for a purchase. Well, I guess it would just be the price for the purchase is all I can think of related. Because a larger item, you'll have to pay more sales tax than a smaller item. Unless you're in Oregon, right? They don't have sales tax. But we're in California, so sales tax would be shifted. That'd be a fun question, though. Like, pretend you're in Oregon and then consider this question. That could be fun, just for like a brain teaser. All right, last quantity relationship conversation. A girl has a bag of flour. Her dog bites a hole in it. The more she walks, the more flour comes out. Name two quantities in the situation that are related. How are they related? Well, the two quantities I'm thinking of are the amount she walks and the amount of the flour that comes out. How are they related? The more she walks, the more flour comes out. They both increase. Now let's think of another pair of related quantities in this situation. Um, the amount she walks and the amount of flour in her bag. So the more she walks, the less flour remaining in her bag. So the related quantities would be her walking and the amount in her bag. And the more she walks, the less flour there is in her bag. I'm sure there's more related quantities, but that's just the one that I found. It's really helpful when you're talking about quantitative relationships to understand how they are related to one another, to find a pattern. So when you find values, you can say how they should work with one another. If you have any more questions, don't be afraid to ask. I'm just an email or a chat away. Thank you so much for listening. If you have any questions, again, I look forward to seeing you in class. Stay safe. Have a great rest of your day.